right. My name is Selena. Thanks a lot, Belinda, for inviting me to speak here today. I'm going to be talking about something that's more of a hobby, which is learning how to teach adults and focusing mostly on women, how to contribute to open source software. But before I get to that, because I have a little time here, I figured I'd tell you a little bit more about myself. Right here, what we have here, since we're all in Portland, some of you from the Portland area may know that I keep chickens. And here is a photograph of our latest chicken coop. My husband designed this. We call it the Chicken Palace. You're actually only seeing a very small portion of the overall structure. And if you look very carefully, you can see a little chicken. That's our chicken Chip, kind of hiding out in there in the window last fall. I also like making diagrams. This is a diagram of all of the locations in my backyard where chickens have died. And I gave a talk about my early efforts in keeping chickens alive. They got me sort of a bad reputation in the local chicken keeping mailing list community. And I think that there's a link. Yeah, there's a bit.ly link there if you want to, see that talk. So like I said, I like making diagrams. I didn't actually make this diagram, but this illustrates a piece of software that I work on at Mozilla. It's called Socorro. It collects and processes Firefox crashes. I work on a lot of data-related things, and like I said earlier, specifically Postgres, but I also try to keep an eye on all of the data storage systems that are related to that. So I get to work with what I call medium data, and I have a great group of people, big team that is spread all across the globe. So this diagram was created by Mark. He sadly passed away a couple years ago, but he certainly had a gift for making lovely diagrams that very prominently feature my favorite database. This needs to be updated a little bit, but it's still pretty valid for the main architectural elements of our system today. And I thought I'd share with you a little more about how we actually get crashes, because a lot of people don't know. So this is Firefox, and you can actually look at your own crashes inside of Firefox right now if you go to About Crashes. And I'm sure there'll be one or none in there, because Firefox never crashes. But anyway, so that thing in there, as you might guess, is a link. And if you click on it, it'll take you to this site. It's crashstats.mozilla.com, and you can have a look at what that crash actually is. Go get your own crash. You can learn a lot of things about it, and I won't go into all of the things that you can learn, but there is one link that I really like, which is More Reports, which you can see right there. And if you click on that, you'll get to see who else has reported similar crashes. And I don't know if you all know this, but we have a comments field. And thanks to that comments field, you can see what other people have to say about your crashes. And that starts with the typical requests for fixes, some commands using some pretty direct language, and also threats. Sadly threats. But if you'd like to see lots of comments, not just about your own crashes, you can go to this site, lqbs.fr/such comments. This is my coworker Adrian made this, and it pulls recent comments out of our Elasticsearch system and displays them on this website. And just one more diagram that I'm sort of proud of. Sorry if this scares any release engineers in the room. I made this diagram a couple weeks ago, and I like to call it How Firefox Made. So if you start up at the top, there's a little more work that needs to be done on this to make it look nicer. But anyway, in the top upper corner is where patches and things go into either Git or Mercurial. And then if you kind of follow it all the way around and come back to the end, you'll see there's an FTP server, and that's where the releases land at the very end. I made this in honor of our release engineering team that came to town a couple weeks ago. One more thing, those magenta bars are places where the process might break and thus close our tree and prevent people from submitting new patches. So anyway, this is the kind of stuff that I really, really love doing. It's exposing exactly what it takes to make things based on what people really do, as opposed to what we wished or hoped or imagined that they might do. And I think that that approach to my work is sort of also how I approach volunteering. And the volunteering work that I've focused on for the last couple years has been about bringing people who are not currently in the open source communities into our open source communities. And I think the most important thing that I've learned about this is captured by this quote, which is, in the beginner's mind, there are many possibilities, and in the expert's mind, there are few. And basically, this whole talk is kind of about this idea. So I'm a beginner teacher. I just started writing lessons in the last couple of years and teaching classes to adult women who are learning or practicing their programming. And all of what I'm going to share today is based on those personal experiences teaching those first-time adult programmers. And I'm really excited about working with beginners because I think this is how I personally can bring more contributors, open source contributors, into our communities, and especially women and underrepresented groups of people. These are the kind of people who have believed for a really long time that they really have nothing to contribute to open source software. And I'm sorry I'm not looking over at you. My speaker notes are here. There's a little group of people off here behind me, and I feel bad. So if there's a single thing that you take away from this talk today, it's this. The next time that you answer a beginner's question, pause and take a moment to consider how that beginner will feel when you answer. And I hope today to give you some tools to help beginners feel successful and excited about learning. And I believe that really all of you already know enough and are kind enough to help beginners succeed in programming, even though it is very difficult to do. So I started out in free and open source software in 1995. I installed Linux on a computer that I put together myself with the help of some friends. And a couple years later, I joined my first ProMongers group, and then I discovered Postgres. But in September 2012, I met a ton of women who were involved in PyLadies. And I was so excited by their mission, their success, that I ended up founding my own chapter here in Portland. And the goal there was simply just to get women together who code to talk about Python. And many chapters have also founded these free programming classes and then published their curriculums online. So when PyLadies started, our first project was to take a Coursera class together. Before we knew it, we had 60 women signed up for these meetings, and 30 or more women were showing up for each one of these meetups to go over the homework together. We'd talk about Python. Well, they were coming there to talk about Python and meet other programmers as well. But many of the women who showed up had never programmed before, and many struggled with the math. Like, one of the first problems was learning how to do modulo arithmetic when you're dealing with negative numbers, which even people who are very good with math have problems with. And there was lots of fancy syntax that they were also struggling with, like list comprehensions. So in a couple of weeks, it became really clear. The women in these classes needed a lot of help. And they needed help with basic programming that wasn't being taught in the Coursera class. So I had to decide, was I going to just let the Coursera class finish and turn this meetup into like any other meetup that we had where we just had monthly meetings, or was I going to try to teach these women who had never programmed before? And clearly, since I'm here, I decided to teach. One of the first lessons that I learned was about choice. The beginning programmers are often so open to possibilities, and they're given 1,000 different choices at the same time. And they really have trouble figuring out what the reasonable next step is in the face of all of those different possibilities. You can think about this problem in terms of the culture of open source software itself. Perl is famous for this phrase, there's more than one way to do it. And it symbolizes the best part of beginner's mind. It's like this place where we're full of adventure and possibility, and we're really inclusive of differences. But when instead of being open to possibility, you just become overwhelmed by all of these choices, there's really no adventure. People are just confused. To illustrate that confusion, let me share with you the old Python download page. There are so many choices on this page for a new developer, and it's improved a lot, I want to say, before you get too scared that this is what it looks like now. In 2012, in early 2012, there was actually this page was even worse. It was alphabetized by topic. So the very first thing at the top was alternative implementations. So you could maybe download and install CPython instead of, something that you might actually need. Sorry. But anyway, so the pilotees that went to this page, they were completely stumped. They were like, which version of Python should I use? What's the difference between the MSI installer and x86-64? They're like, should I install from source? Oh God. So anyway, so that was really bad. So this is what the Python page, the landing page looks like now. If you want to download Python, you can see first of all there's some parachutes. Thank God, helping us have a safe landing wherever it is that we're going. We don't know, but anyway. It auto-detected the operating system, which is also very nice. Unfortunately, we're also still providing this choice between 2.7 and 3.0. But there's a link that's like, hey, you can try to find out a little more about this. Obviously, there's a little more work to do here, but now it's much more clear. Here's where you're supposed to go. And especially if someone's there with you, you've got only really one choice to make. So I show that to you because I think our job as a teacher is to answer this question over and over. What do I do next for the student? And not every student, of course, is going to need that kind of help all of the time. But at some point, nearly every student is going to need that kind of help from a teacher. And they need that help to discern between, to discern between the different types of choices that are in front of them. And when we help students decide which step to take next, we have to take into consideration the experience, how that experience makes them feel. If we're helping them, but they don't feel confident in their actions, they haven't truly learned what we're trying to teach. So I think it's not just our responsibility to give them the correct answers, but it's also to enable people to confidently solve their own problems the next time they run into them. So to try to figure out how I can help students feel more confident, I decided to look at what my own emotions are like when I'm learning a new programming skill. So this is a picture of a sticky note I drew, and I call it my minimum viable despair graph. I drew this right after I was learning a database migration tool, which I'm sure fills everyone with joy. It's called Alembic. It's actually really cool. So you can see I ended up above the minimum viable despair line there. So the top of the graph is euphoria. The bottom is despair or unhappiness. And you can see I have a lot of ups and downs as I'm going through. And those peaks are like when I'm reading the documentation for the first time and I think it's going to solve my problem. You're succeeding with experiments. I'm implementing code that's sort of working. And the valleys are when I actually try the tutorial. It doesn't really work. When the code just fails, for who knows why. And then when I'm trying to refactor my test suite. In the end, though, my emotions sort of level out and I adopt the tool because it worked out for me. So what does it look like when somebody tries to learn how to program for the first time and they do not succeed? Well, here's my scale again with the euphoria at the top and the despair at the bottom. And here's what I think happens. And this happens with PI ladies when they come and they just never come back to a meeting. In one case, I know exactly what happened, which is the woman came, she set her laptop up, it was a Windows laptop running Python, and then just something broke in her environment, and she couldn't run Python again. And she was like, oh, that's it. This is just too hard for me. And she just never came back to the meeting. She told me about it, which thank you for telling me at least. But she was like, yeah, this is just too hard for me. I can't do it. So what happens when PyLadies succeeds? Well, here's an example. There's still lots of peaks and valleys. There's probably more peaks and valleys. But in the end, I think we end up having excitement for programming. And this is what I've seen in the more than 200 women that keep coming to meetings, is that they continue to have these difficult experiences, things break, sometimes they know how to fix them, sometimes they don't. But they keep coming back to the group. And they ask questions, they get to commiserate over things that don't work, and they get the help that they need to feel like they can continue with the work that they're doing. And they have an opportunity to feel as though they're getting better, to make friends and be supported. So what we're doing in these hackathons and meetups is getting, well, what are we doing in these hackathons and meetups to help people get through these pits of despair in programming? Well, from a teaching standpoint, here's what we try to do. We try to address the unwritten first chapter in open source development, and there's a lot in that chapter. There's so many details that we take for granted, and for first-time programmers, they really struggle with our tools and our installation practices. Our classes really try to help them through this. We set big goals, like for a lot of people, getting a job. They want to change careers is a big goal. They might want to give a presentation at a conference, or they want to write their first open source application. There's these big things that they want to do, and we try to help them with that. We try to provide them with early wins, like collaborating with established projects, getting through tutorials successfully, and demonstrating new skills as quickly as possible. And we try to make lots of in-person connections so that you have friends to code with. We cultivate a learning environment, a special place that really encourages people through learning and fun, and I'm going to talk a little more about that in a minute. So there's quite a few tools for making these 5 things happen, and I'm going to describe a few that hopefully you can use right away, like in your work, in open source groups, and maybe with your families, because I think really everybody should learn at least a little bit how to program so that they understand the way that the world really is changing quite a bit. So a couple of my favorite tools are these 2 ideas from Hacker School. It's a writer's retreat for programmers. How many of you heard of Hacker School? Just a few of you. Oh, awesome. So 2 things that they do. First of all, they ban the phrase, well, actually. When someone starts a sentence that way, they're correcting someone. And the truth is, teachers rarely need to correct people to be good teachers. Mostly, you can ask students questions, help them come to a good solution on their own, and banning well actually is just a reminder that those corrections are often not needed. The second part of this, when you act surprised that someone doesn't know something, you're really causing shame. The person feels shame that they're admitting that they're vulnerable, that they know quite a bit less than you often. And this thing of no feigning surprise is just a reminder that we all need encouragement. And admitting that you don't know something takes courage, and that teachers should always be rewarding courage. Another really great tool is pairing. Students who have just learned new skills are often the best teachers. And if the students are struggling, they may find it much easier to ask their peers questions. And if both students are having the same issue, then they can try to solve that problem together or ask a question of the teacher. And finally, they can face it together and not be embarrassed or alone while they're struggling. And for the teacher specifically, I really encourage people to spend way less time lecturing in front of the class, although I'm just lecturing and lecturing today. Spending more time helping students practice new skills. My rule of thumb is really about 1 minute of instruction to 3 or 4 minutes of practice time. And I try to only prepare about 15 minutes of material so that really happens instead of over-preparing. And this helps keep the classes moving, interesting, and the students far more engaged. And finally, I think that teachers really need to listen very carefully to how students phrase their questions. The students will often rephrase or ask an important question when the lesson isn't clear. If you record what you're doing or just write down the questions as they're asked or have someone help you with that, that can provide you with really important clues later on how to make your lessons better. So for example, we had a student come in and compare objects and classes to cookie cutters and cookies. And the students were able to use that metaphor. They just, tons of people grabbed onto that and were able to repeat it to other people who had missed the lesson the next week. And prior to that, I honestly, whatever examples I came up with were not as effective as that one. And I learned that from the students coming to the classes. So I've been using these tools with PyLadies since about September 2012. There are now about 250 women involved in the user group. We've got, I think, 5 or 6 people who have started their own special projects related to Pilates, either a Coursera class they got together or like, a research project they're working on together. Pilates overall globally, we have more than 25 chapters. They're mostly in the US, Canada, and Europe, but we now have one chapter at least on every continent, including Australia. But I think the real secret to success of these meetings is the regularity with which we have them and the opportunity that we provide for women to work directly with one another. So I'm seeing more and more women meet up in Pilates and tell me, exactly what they think they're getting out of it. And of course the new skills, thank goodness, or else like, what am I here for? Something that I didn't really anticipate or plan for as much was the peer support. Like there's been different problems with people, problems that people face when they're first entering into a new industry. And they're special problems that like I didn't necessarily have, because believe it or not, I've been in this industry for 20 years now. And there's just issues that they're facing that they were able to talk to each other about and face together that I wouldn't have been as effective helping with. The regular meetings provide them structure and routine. Otherwise, they might not come back to that homework assignment, but they've got peers that are working on it with them. And the other thing that people have told me is that they get confidence. They practice using Get with each other and learn from each other, and then they're able to go into an interview and use that knowledge in that interview. And that's been extremely gratifying for me. So there's another community that I've been involved with for a really long time, and that's Postgrad, of course. Spend most of this time talking about Pilates, but there's something about Postgres that I just wanted to touch on briefly and that I mentioned in the abstract. It's our code review process. And I think it relates very much to something that's grabbed my interest recently, which is code reading. So Postgres has had a pretty rapid pace of development for the last 5 or 6 years. We're doing a release every single year. At about the same time, which was a big accomplishment for us. As an open source project that doesn't have any major, any single major commercial backer driving our release process. We're doing it all as volunteers. But we have this very carefully documented code review process. So I just wanted to talk about that a little bit because I think it leads to code reading, which I think is a fundamental skill that helps you go from being a novice to an expert programmer. So in case you didn't know, I probably shouldn't even have this slide because it's not very fair, but whenever I talk to people about contributing code to Postgres, one of the first things that they tell me is that they're scared, which is really sad. They think of even tiny patches getting contributed to this code base as some sort of Olympic feat. Even though we actually have this documented process and 300 or 400 people contribute to the code every year. And so hopefully I will demystify this, and if any of you are interested in database internals, which hopefully there are a few of you, you'll try it out. So here's a document that the community made, and I'm gonna post these slides, but you can also just search for review a patch in Postgres and you'll find it. Greg Smith wrote it in about 2008, and since then many people have contributed to it. And I wanted to go over the key features that we have in this document. It's broken down into what I've found to be a very accessible checklist. Like we'll have these things called patch review parties. Sounds like a lot of fun, right? Where we get together at somebody's house and go through the backlog of patches and just try to see if there's any that interest people and work on them together. Well, I think this is one of the most important parts of the document. A lot of people who work on open source software already believe this, that they don't have to ask permission, but we explicitly tell people you don't have to ask before you start reviewing a patch. Just go after it, and we're grateful for the help. We also give a timeline. Like if you get started on it and you haven't been able to do anything in like 5 days, please kick it back and somebody else will have a crack at it. And then we break the review process down into these very explicit chunks. And not only that, and there's way more on the wiki page than I'm describing here, but we name it, and then we describe the skills that you're going to need in order to tackle that patch. So for example, for submission review, we need you to be able to use the command patch and have some English comprehension, which, you can learn how to use patch in a day, And a lot of the people who are contributing to us are very good with their English, so that's great. We have a usability review. There's some kind of a test that you might need to run, and there's usually instructions that come along with it to run. And then you need to be able to find the email that describes the spec. And after that, there's a feature test, which is a feature review, basically. And there, again, patch. You might have to compile. Well, you will have to compile Postgres probably. And then if there's any errors when you try to actually test the feature, pipe that to a log. So these are very basic things that I've taught pilotees, like how to do this type of stuff, and they could go in and do these first three things without really having an in-depth knowledge of Postgres. So the reviews do get progressively more difficult, and we have them listed in this order with that in mind. Performance review can often be very difficult, especially if you're not really sure what the original performance might have been. Then we have the in-depth coding review where you go through and compare to the guideline, which actually a lot of people could do without too much help, but then portability issues and then detailed C knowledge is required. And finally, architecture review, which there's, maybe like 30 or 40 people who are capable of doing an in-depth architecture review. So anyway, as things get progressively more difficult, we explicitly tell people you don't have to do every single one of these things. If you just pick one of them, that helps us out a lot, and we appreciate that. And then finally, a thing that I love about this process is that we explicitly point out that we need someone to go review the review and make sure that all of the steps in that process were taken. It points out a little bit of housekeeping that's often overlooked and can either be seen as someone else's job or just implicit or not worth mentioning. But we do really think it is worth mentioning, and we acknowledge this kind of cleanup work as an important part of the project management and real work that people have to do. So what I've been thinking about lately in this regard is how we teach through this process people how to critically examine code. This is called code reading in the literature, and I think that in an English class it might be assessed something like reading comprehension. But I've never seen this skill explicitly taught in class. And I almost never see open source projects lay out such an explicit process for their code review. And I think this is one of the special skills that the Postgres community has developed as an organization. And we have a few cultural reinforcers for developing that code, developing that culture as well, developing those habits. So one thing is that we ask people to discuss changes before they write a line of code. The community very much emphasizes being able to talk about the what, the why, and the how, even before you make a proof of concept. And I think that this really also ends up forcing you to read a lot of code because people will direct you back to relevant parts of code, relevant patches, relevant mailing list threads that you need to go through. And again, reemphasizing this, a critical part of our design process is thinking about how people will use the feature first before thinking about how the internals will function. Sorry. Again, I think this really reinforces code reading because people are directed to go to similar interfaces and learn from them before they write their own implementation. And finally, this is a really weird one that a lot of people don't like. I think it really encourages careful code reading because we're saying all the design, the style of the adjacent code, don't just rewrite it to match exactly some other arbitrary spec that we've designed. Postgres is a very old code base. It's like 20 years of code in there. And it may seem sort of strange that we've allowed so much diversity there, but I think it reinforces this idea, read this code, understand it before you make changes to it, and then have your code and the way that you're thinking about this fit into that design. So I still have some kind of new forming thoughts about code reading. One thing that I've changed about my teaching is that I ask people to review each other's code both before and after executing it. Sometimes that just enables simple syntax error, checking, but other times people find interesting and innovative solutions to a problem that they otherwise wouldn't have seen. Or they learn something about the way that their coding partner thinks about the problem. So I think it sparks conversation and hopefully trust that you can share what it is that you're working on without being embarrassed, and sort of in a safe code review environment. So we start really small. People will have like 4 or 5 lines of code that they'll review immediately, right after they've written it. Yeah, and I've picked up a book on code reading, and I'm sort of interested in it for myself, sort of the way that people read papers. But I really hope that our open source communities start doing more of this with their own code. So anyway, so to bring all of this together, I just wanted to share briefly what I think I've personally benefited from, and then I'll let you get out. It's kind of warm in here. Oh my goodness. Beautiful day out, brings the sun and the heat. So I think that I write way, way better code. I've gotten a lot more concise, and I've gotten really good with Git workflow and rebase in particular, because I've had to learn it really well to teach it. I write way better documentation because I see firsthand how beginners respond to my terrible, terrible documentation. And I've gained a lot of perspective about how people who are friendly and interested in open source experience our communities for the first time. That first experience, to say the least, can really be a struggle. And I work even harder with PyLadies to try to make this easier. I've recruited another 250 women to engage directly with the Python community. And I regularly attend, before I was doing PyLadies almost exclusively as my kind of volunteer work, I would regularly attend user groups, conferences, and meetings where I was the only woman in the room. And I'm very happy to see so many new women joining our communities and them coming into my open source communities that I've been part of for a really long time. And here are some organizations that I work with directly, and these are working on increasing the number of women in underrepresented groups' participation in open source. If you have any questions about any of these, please ask me or check out their websites. I think these groups are incredibly important, and I think they're all making measurable progress on this problem today. And finally, I wanted to close with what I think are the most important reasons why teaching and learning how to teach are worth your time, and why I gave this talk today. I think teaching beginners helps everyone become more knowledgeable about programming and what it really is. There are still so many people who have no idea what code is, and we all know this in this room. We're related to, or married to, dating people who who have no idea. My husband is a social studies and an English teacher. And when he learned what variables and loops were, he said to me, "I can't believe I allowed myself to be ignorant of this for so long." And I felt terrible. I said this because it's like my fault. You're married to me. But the concepts really, honestly, aren't that hard, right? Like, this is really basic stuff. I mean, you explain to someone how a stanza of music, a repeating stanza works, and there you have a loop. But anyway, ultimately, I think that computational thinking literacy, if you've never heard that term before, it's worth looking up and learning what that is. I think it ultimately is a civil rights issue, and it's quickly becoming as important as reading or writing in order to be able to participate in public life. And I also want to talk about something that Julie Horvath said last year. She wrote a blog post about women in tech, and one thing that she said just has stuck with me and sort of makes me a little verklempt when I think about it. But she said, "I didn't grow up thinking I could do anything that I wanted to." And every time I read this, I feel a little bit overwhelmed by how much it matches what I see when these women who have never programmed before come into these classes. So what I do see every time I walk into one of these classes to teach beginners is this fear and this feeling like they don't know what's possible, basically. This is a photo from a class on algorithms. I think I showed it earlier. And these people are doing a pen and pencil exercise in writing out how to get from the airport to home using like 3 different methods. And so they worked through this in groups together. And when they left, so many of the women said, they finally felt confident that they could explain what an algorithm was, and that before that they'd come and kind of worked in these groups, they'd literally never thought about the relationship between algorithms and programming, or that they could design their own algorithms before. So I've come to think of this as a possibilities problem, and that people really have no idea what's possible for them in computer science. And I really think it is our job to help them figure this out. So I don't think anybody else is going to do it. But if we make the time, we spend the time making these communities better, we'll definitely make a much better world, I think. And it's a world where not only will people know about programming, but our friends and family will appreciate our work. And it'll be a world that has a lot more open source contributors in it if I have my way. So thank you very much for taking the time today, and please go out and teach.